Thank you.
I'll give you a hint, when you're at the end, it should be equal to 5p. Does that help?
No, but
I mean, I give you a point for that, so it's gotta be somewhat helpful. It doesn't help the intermittence test. Use what we did previously, guys, when you get to that k+1 step, and then what's that? Little sneaky stuff.
Stuff going on there.
Just to kind of get people going with this, okay? After we get to this point, does somebody think we might do the next step at that point? Donnie, what do you think, sir?
I don't know, but can you just do the 7 minus 2 to make it fast instead of?
Unfortunately not, no, sir. They're not like terms. Donnie, remember, like terms have to have the same base, okay, and the same exponent, okay? So unfortunately not. That's right, because that would just give you 5 to the k+1. So please don't do that ever again, though. So Lauren, what do you think?
Do you do the 7 times 7 to the k minus 2 times 2 to the k?
Okay, so 7 times 7 to the k minus 2 times 2 to the k. Okay. So let's say you guys did all that stuff, okay? And even if you didn't know the next step, and then you wrote the stuff that was at the end, like, you know, at that point, I'd probably give you at least like 9 out of 15 points for that. Okay. So,
are you allowed to rearrange it to that point where you can match you can do the induction step, if it's still something you have to do until then?
well, there's still a couple more steps we have to do in that point, okay? So we can't combine like terms yet, but I just wanted to kind of give everyone a hint as to how to start that. So Maybe somebody figure out the next step,
Five
right?
plus
you
two.
got sneaky computation rule.
Okay, so,
Alright, which I couldn't decide if you do it for both the 7 and the 2, so
Ah,
I did do it
okay.
for both the 7 and the 2.
well, that's a good question. Okay, so what do you guys think? Would you have to do it for both of them or just
No,
one?
just one.
John?
You do both of them, you do 5 plus 1 plus 1 plus 7, and then 1 plus 1.
Okay, or, there's another, you're right, you could do 5 plus 1 plus 1, because remember, you're trying to get to
That divisible.
1/7 to the k minus 2k.
Or they can do 5 and 2 and take to the common.
Or you could factor out a 2 once you've done that, okay? So both of you guys are correct, okay? Joe, John, do you mind if I just do 5 plus 2, factor out the 2 from there, and then use induction, just because it'll save one step? But your way is absolutely correct, okay? That's excellent, okay? Yeah, guys, you don't have to break up this one right here, though you could. In fact, what I'll do is I'll do them both when we're done with this, so that way everybody can see like what John was talking about, what Art was talking about. Or I was thinking about it your way, just because I'm lazier than John is.
Like me.
So I'm not calling you lazy.
I'm
Okay.
lazy, I don't
Okay,
mind.
you're lazy. You can call yourself lazy then.
I don't mind.
But we do that sneaky trick where we can write 7 as 5 plus 2 times 7 to the k. And then we can leave the 2 times 2 to the k alone. Okay? And I'm going to do it also the way that John suggested after we're done, because maybe some of you guys thought of the way that he did too. Okay, I didn't think of doing that because I don't think that's smart. All right. Then we can distribute the 7, right guys? Okay. By the way, how many guys broke it up as 5 plus 2? Just kind of thinking about it. Okay, that's good. Okay, because you knew it had to have a factor of 5 somewhere in there, and 5 plus 2 is 7. So I think that's a good way to think about it. Okay, and then we could distribute. We can get 5 times 7 to the k plus 2 times 7 to the k minus 2 times 2 to the k. Okay, that's just distributing. And guys, see how there's a common factor of 2 right here? Couldn't we factor out the 2 just from these two terms? Okay, let me do that over there, just to illustrate. Okay, so this would be equal to 5 times 7 to the k plus, factoring out a GCF of 2, that would give us 7 to the k minus 2 to the k. And guys, can't we see inside those brackets? What do we know about 7 to the k minus 5 to the k?
There's A.
It's equal to 5p, right? Or 5a, what do we call it? We've called it 5a. It's the inductive hypothesis, right? So this is now equal to 5 times 7 to the k plus 2 times 5a. Right? And now we know what to do, right guys? Once we get to that point, all of us see that there's a factor of 5. Let's yank the 5 out. So we're going to factor out our 5. We would be left with 7 to the k plus 2a. Okay, and then by closure, that would leave us with 5p where p is an integer. Okay, let me fill in the steps, and then off to the side, I'm going to do the way that John suggested to do it as well, which I really like. Okay, it's just one extra. In fact, it might not even be an extra step. I don't know. Okay, so this was just our exponent rules. Okay, this is computation. This is distribution. And then GCF, closure, or GCF, I'm sorry, induction. GCF again, and then closure. All right. More fun than stabbing yourself in the hand with a knife, right? Just barely. All right, so. Unless you're into that sort of thing. I mean, no judgment. Whatever you're into, that's cool. All right, so, guys, any questions about that? Pretty sneaky proof, right, guys? Okay, as we're seeing, like sometimes we need to train ourselves sometimes to do the opposite of what we've done all of our lives, right? All of our lives we know combined like terms, right? Now it's like uncombined like terms, okay, which is, it's completely different. I mean, think about that. For 20, 30, 40, 50, 60 years of your lives, you guys have been doing combined like terms, and now all of a sudden in 1 week, I'm telling you guys, don't always combine like terms. That's difficult to do. Okay. All right, let me go ahead and do what John suggested, just so that way, if anybody guys tried it this way, I just want to show you that you could do it this way. Okay, so all alternatively, when we got to this point with 7 times 7 to the k minus 2 times 2 to the k, you could have written it as 5 plus 1 times 7 to the k minus 1 plus 1 times 2 to the k. Okay. Be careful with your distribution right here, okay? What you might see, so 5 times 7 to the k plus 7 to the k plus 7 to the k. This is what I might often see a student do. They might only distribute the negative to the first, so minus 2 to the k, and they might accidentally write plus 2 to the k, but this negative should be distributed to both of the terms. Okay? And guys, can't we see that there's actually 2 pairs of that 7 to the k minus 2 in there, right? So we could use induction on this pair right here. And then we could also use induction on this pair right here. So that would be equal to 5 times 7 to the k plus, we would have a 5a plus another 5a, okay, by induction. And that would leave us to the 2 5a's, okay? So John, I think the method I was thinking was just one step quicker, all right, but yours is much more discrete than what I was thinking of, which is better because this is called discrete structures. So I guess you win on this one. Good for you. Next time it's my turn. All right. Guys, any questions about how to try to do one of these types? Okay, and you guys would be okay maybe doing what the previous type that we saw, where we just have maybe one exponent. I think we said like 6 to the n minus 1. If you guys had something like that on the exam, you'd be okay with that one. Okay, so make sure you guys study something like that. Okay. I want to go through and just show you a couple examples of being able to do the inequality types, okay? And then we'll spend the rest of the time talking about what's going to be on your examination, okay? So, I'm going to show you guys one with a polynomial and exponential, and then I'm going to show you guys another one with an just exponential.
Don't erase the right.
Oh, this guy right here?
The right, don't erase.
Oh, okay. Even though I started erasing it. Let me fill it back in if I can. There we go. You're welcome. I'll try to keep that up as much as I can. Okay. So for this one, we have for any integer bigger than 3, 2n plus 1 less than or equal to 2 to the n. Right. Now, unfortunately, guys, this is a different type of animal, again, induction, because we can't use substitution. Okay? With these types where we have inequalities, we're going to have to try to build the k plus 1th term out of this by using algebra. Okay, so a little bit steep here. The first 2 steps are easy. Okay, so step 1, okay, let's let n equal 3. Well, duh, that works. Okay, 2 times 3 plus 1 is going to be less than 2 to the 3rd. Or in other words, 7 less than 8. Okay, so that works. Okay, I don't think anyone in here doubts that. Okay? So at least if you can do that, you get a point. Good for you. Okay? If you want another point, you'll say, thus the basis step holds for small values of n. So thus basis holds for small values of n. Then we assume the result holds for all n equals k. So assume the result holds for all n equals k, where k is an integer. Okay. Thus, 2k plus 1 less than 2 to the k. All right. All right, so is everyone okay with that much, guys? I mean, that's easy stuff, okay? All right, now the tough part for this one, and I'm going to put this in brackets, okay? You don't have to write this. For this type, we can't use substitution. Guys, what happens if you use substitution on the original inequality for this?
2k plus 2 is less than 2 to the power k plus 1.
Which is exactly what we're trying to prove.
Oh, yeah.
Right? If you substitute it, you're actually just putting it in there and you're basically begging the conclusion for this, okay? So you're just jumping to the conclusion. It's almost, in fact, it is a converse error when you're just saying the conclusion is true based on the original you're saying that the premise is true based on the conclusion. We can't do that, okay? So, for inequalities, okay, so let's just write a note here. Inequalities. Do not substitute k plus n equals k plus 1. Okay. Rather, let's build the k plus 1th term. So we'll build the k plus 1th term. And it's not going to be a lot of steps, but it is a little bit sneaky to do this. Okay? As you guys are finding, a lot of induction is sneaky. Okay? The only thing that we know is that 2 to the k plus 1 is less than 2 to the k, right? Didn't we already assume that by induction? Okay, so we're going to say that by induction, 2 to the k plus 1 is less than 2 to the k. Okay, so that's induction. Now, what I have to somehow do is I have to use my laws of inequalities. And remember, you can add stuff to both sides of an inequality as long as the inequality holds true. Like, for example, and don't write this down, okay, but I'm just going to go over here. And let's say for some reason I had 7 less than 19. Okay, that's true, right, guys? Hopefully it is. What if I did this? What if I said 7 plus 6 is less than 19 plus 99? Okay, is that true, guys? Yeah, because isn't